Hi, and welcome to another episode of Inside DevOps. I'm your host, John Bristowe, and joining me on the show today is Michael Levan. Michael is a former employee of Octopus Deploy, but recently he's been spending a lot of his time talking to the community around Kubernetes. He has a lot of training materials. He's got his own podcast. He's written books. Michael, I'm not going to bore people with your bio, but you've done a lot of stuff around Kubernetes. You've got the latest book here. I've got a copy of it. I think I have the only copy of it in Australia, 50 Kubernetes concepts every DevOps engineer should know. It's a pretty good book, actually. I've been leafing through it, and you've got a lot of stuff in here for obviously folks who are managing and deploying solutions to Kubernetes. Tell us a little bit about the book.
Yeah, so the idea of the book was, I like to think there's two certain categories. There's the Kubernetes book by Nigel Poulton, awesome book. It's one of my three references that I always go back to. Like I always have it up on the Kindle app, and always going and just referencing it and stuff like that. And then there's the production Kubernetes book by O'Reilly. I always forget the authors, but I believe at the time, at least when they wrote it, they were all engineers at VMware, right? So you have the Kubernetes book that's very entry level, just like getting you to understand what Kubernetes is. And then you have the production Kubernetes book, which is like, it goes very, very in depth. Chances are you might not even have to go that in depth unless you're focusing really, really hard, specifically on Kubernetes implementations. I wanted to have something that was like in the middle, right? I wanted something that was not super entry level, but gave you an understanding of Kubernetes as a whole, but how to think about Kubernetes in production. And I'm taking that knowledge based on, working with Kubernetes since 2016, 2017, consulting for customers globally at the moment on Kubernetes projects. So I kind of took this whole idea of, okay, not just what the knowledge is of Kubernetes, not just how to use it in an advanced or an expert level perspective, but how people are actually using Kubernetes in today's world, and that just makes up the entire book essentially.
It says here the book equips you with all of the requisite information about how Kubernetes works and how to use it for the best results. You'll learn everything why cloud native is important for implementing Kubernetes clusters to deploying applications in production. So let's talk about deploying Kubernetes to production. Obviously, when looking at moving to production, obviously, it's not just right click and away we go. There's a lot of stuff that comes involved. So using Kubernetes in production, one of the things that you espouse heavily within the book is obviously making sure that you plan before you jump in. So can you talk a little bit about that?
Yeah, so I like to kind of split up my thought process in, and not to sound too buzzwordy, but day zero, day one, day two ops, right? So you have day zero ops, day one ops, day two ops. Day zero ops for me is really architecting, planning, what type of tools you're going to be using, why you're going to be using them, what solutions you're going to be going with, why you're going with those solutions. And in my opinion, at least, and in, everything that I see in this space today, engineers are so focused on just getting the job done because management and leadership, et cetera, is always breathing down everybody's throat saying, we need to get this done in X amount of time. You need to go, go, go. We need to get this out the door. So there's not a lot of time for engineers to actually plan out why they're doing things. And John, as you and I know, this leads to a fun thing that we all love called tech debt. If you don't plan, if you don't get everything the way that you're supposed to from the start, or at least 80% of the way there, because of course, as we know, everything changes. If you don't plan everything correctly from the start, you're going to be going back and refactoring it anyways. So you might as well just do it right the first time. And that's where the planning and the architecture phase comes into play.
What are some of the things that you're recommending to customers in terms of their planning? Conversation, obviously, with the engineering teams, but does everyone need to get upskilled and educated on Kubernetes? Do you find in your experience, or are people pretty much up to speed? I mean, they talk about it being the cloud operating system, so you would assume, okay, everyone's kind of knowing what's going on. But do you find that with engineering teams, as you're talking to them around planning, they realize that, wow, this thing's actually pretty powerful. There's a lot of knobs and buttons to consider. Or is it just one of those things where, like, obviously an education around scaling, things of that nature? What happens in those conversations that you're experiencing?
Yeah, so I'm going to quote a good friend and colleague of mine, Eric Wright. He said Kubernetes right now is what VMware was in 2005, 2006. So right now, Kubernetes has gone from an idea to, oh, this thing's pretty cool, to, oh, a few people are running this, to, oh, this is the thing that's running in production now. It has like kind of taken this whole phase, and now everybody's like, okay, we're going to now run this thing in production. Now, of course, there are other solutions, there are other platforms, there are a million different ways that you can run application stacks. However, from a production perspective, we're seeing a lot of Kubernetes today, just based on various tools. The cloud providers are putting heavy efforts into Kubernetes. So do people need to, get upskilled in Kubernetes? Yes, I would say so. Are there prerequisites to getting upskilled in Kubernetes? Absolutely. I have a full blog post that's very lengthy that essentially says these are all of the things that you should know before you get into Kubernetes: storage, infrastructure, scalability, networking, especially networking, light programming, how application stacks work, how binaries work, how dependencies work, etc. There are all these things that you need to know before you can even think about Kubernetes. But to answer your question, yes, I think at this point, everybody should definitely be thinking about Kubernetes. Now, do you need to be like folks in Kubernetes 24/7 doing nothing but Kubernetes? No, it's unrealistic. If you're a DevOps engineer, if you're a platform engineer, there's going to be a million other things that you have to do.
VMware recently published the State of Kubernetes report in 2022. This was last year, but a lot of it's still relevant. And in there, they cited number one, improved as their benefits. Number one was improved resource utilization, and two, eased application upgrades and maintenance as the top two benefits associated with Kubernetes. The third most popular benefit cited was it enabled our move to the cloud, while the fourth was most popular benefit cited that it enabled a hybrid model between public cloud and on-prem. Obviously, I would assume you agree with resource utilization being the top operational benefit for using Kubernetes.
Yeah, absolutely, 100%. There is the aspect of what resource utilization can do in Kubernetes, but then there's also the aspect of managing resource utilization in Kubernetes. So we've kind of like seen this trend right throughout history. You had mainframes, you had servers, you had VMs, you had cloud. Now you have containerization in Kubernetes. WASM is becoming a thing as well. So the trend that we see through timelines is always smaller form factors, all while still having the same performance and outcome. So, yes, the idea of containerization essentially takes the smallest form factor possible and runs your binaries the same way that you could on bare metal or on VMs. However, from a resource optimization and a cost optimization perspective, it's becoming something where uh, pods, containers, etc., are now taking far too many resources than they actually need. So worker nodes are getting scaled up for no reason. CPU and memory and storage is out of control. That means costs are out of control, and because of that, you're seeing now a lot of resource and cost optimization tools kind of popping up. Right? You have Cast AI, you have KubeCost, you have Sysivio, you have a bunch of different tools and platforms coming up that are ultimately trying to fix this problem. So we've kind of went from the idea of resource optimization is great, you can use Kubernetes to have resource optimization, and now we're at we have 20 worker nodes running for no reason because we haven't put limits and requests and quotas on our pods and on our namespaces and on our application stack. So there's kind of two levels of that resource and cost optimization there.
Yeah, that actually mimics what I read in this report from Fairwinds. This is the 2023 Kubernetes benchmark report that talks about the state of Kubernetes workload costs. And as you can see in the report here, they talk about CPU requests and limits. The good news there is that when setting these factors, shows that 72% of organizations are only setting up to 10% of their workload limits too high. And then only 1% of organizations had 100% of their workloads impacted by CPU limits that were set too high. And obviously, when it comes to resources, it's more than just CPU. It also applies to memory. And then as you read the report, it talks about other aspects as well. So obviously, allocation of resources relative to Kubernetes is super important. You want to keep costs under control. And obviously, the reporting aspects that are available in the industry today turn out to be super important. Or do you have a favorite sort of solution, or do you have any recommendations that you'd you've talked a little bit about them, but do you have anything that you would recommend folks keep an eye on?
Yeah, so I'll preface this with I am on the technical advisory board, but Sysivio is one of my favorites, hence why I'm on the board. Great team over there, great product. They have a lot of stuff from a resource optimization perspective, and not only telling you what's happening in your environment, but they give you the remediation steps. So like they give you, the actual description and the code and all that you need to fix the problem, and you can automatically do it from the solution. Literally press a button and it's fixed. And the reason why I'm saying that is because there are a lot of resource optimization tools out there, but and they do that. They give you, they give you the example, or I'm sorry, they give you the reasoning of what's happening. Then some of them give you the remediation steps, not all of them, but as far as I'm aware, Sysivio is the only one that's giving you the button that's like, go fix, and then you go fix. In terms of cost optimization, I personally like Cast AI. I'm not affiliated with Cast AI in any way, but I do like them because, again, they give you that button. Like it's not just giving you the information like, hey, your bill's really high this month. Cool. What can I do about it? They're actually giving you a button that you're clicking and you're remediating. So that's how I believe the tools should be. You should have the ability to see the information, but then you should also have the ability to do something about the information. Because if you can't, you're really just looking at a fancy Excel spreadsheet at that point.
Obviously, that speaks to the reality that most people kind of face when they look at Kubernetes, which is either you roll your own, meaning hosting and on-prem, or versus what now is available through the cloud providers, Azure, GCP, AWS, etc. Um, are you a fan of? Let me start by asking, which one do you prefer on the cloud side?
So I'm very agnostic, right? But I do like three. I do like all of them, but for different reasons, and some of them shine where others don't. So I'll break it down in a high level way, and you can feel free to ask me any questions that you'd like. I love GKE. Why? Because they have the most options. Why do they have the most options? Because they created Kubernetes, right? So it makes sense that they would. They have everything from Anthos to Service Mesh built into options that literally help you migrate to containers. You just take your binaries and you can migrate them to containers. No other solutions that I'm aware of in the cloud have that at the moment. AKS I like because, in my opinion, it's the easiest one to configure. Number one. Number two, Azure AD. RBAC is a huge problem from a security perspective when it comes to Kubernetes. It's incredibly cumbersome to use the RBAC resource in the core API group in Kubernetes. Azure AD, I mean, it's built in. Active Directory has been the authentication and authorization protocol for 20 plus years, and it works just flawlessly, right? So I really, really like AKS because of that. I like EKS because it gives you, how can I put it? It gives you the option to have both on-prem and in the cloud. So you have the ability to use EKS anywhere. You have that in the other cloud providers as well, but I do like EKS anywhere. And it gives you the ability to also have it, in the cloud. And the other piece about EKS, not necessarily a featured, well, I guess it would be considered a feature difference. They have Fargate profiles. So Fargate profiles, and GKE has autopilot as well, but Fargate profiles I think are a little bit more like production ready in the sense that they've been around a little bit longer. Um, Fargate profiles allow you to abstract away worker nodes. So in EKS, AKS, GKE, you don't have to worry about the control plane anymore. Now with Fargate profiles, you don't have to worry about the worker nodes anyway. So, like at all. So it's literally serverless Kubernetes at that point. Like you're not, everything is abstracted away from you. The only thing that you're worrying about is the infrastructure and network layer of scaling and making sure everything's secure in the application stack. So I like them all for different reasons.
So that's interesting. So obviously, you're building a strong case for cloud-based Kubernetes, but obviously, this conversation comes up a lot. I would imagine with the customers you're talking to, which is basically rolling your own versus what's available through the cloud providers, the big three. What would you suggest when people are looking at that? Obviously, it's I guess it's mostly a control issue at that point, is it not?
It's a control issue, it's a flexibility issue, and it's a feature issue. So let's say you look at Mercedes, the car dealer, right? Their tech team runs Kubernetes, and they have over 1,000 Kubernetes clusters. At that level, and that maybe makes up 5% of the population that's running Kubernetes. It's a very small amount. But at that level, you need to have certain control, as you mentioned, over how things are running, where they're running, et cetera, the different tools, different platforms that you're using, all of that good stuff. So they're running everything on OpenStack. So they have their own private cloud, but they're managing all of the bandwidth. They're managing where the clusters are running. They're managing their single and their multi-tenancy at, a flip of a switch type of deal. So thinking about the flexibility and the features, let's talk about two different things. So first, let's say you want to go the Cilium route for your container network interface, your CNI, because you want the security feature. So one of the things that Cilium gives you is the ability to encrypt east-west traffic for your pods without having to implement something like a service mesh. AKS has just released it in preview, so it's in beta, right? So when you go with a cloud provider, you lose the flexibility of using certain features, right? So if you want to like call a CNI a feature, it's or a Cilium a feature. It's not a feature; it's a plugin, of course. But if we can put it in that feature category, you lose that flexibility to utilize a certain product with your environment. Now, the other thing is you're also losing. There's certain defaults that are set up in the cloud. So, for example, if you're using AKS, EKS, GKey, you automatically, unless you otherwise specify during your environment deployment with a click of a button or code or whatever, you get a public IP address associated to your control plane. Is it the best practice? No. There's no reason to have a control plane public unless you give me some type of compelling reason of why you cannot set up a VPN or set up certain rules, et cetera, in your virtual firewalls or in your virtual VNets in the cloud. Unless there's a compelling reason, there's no reason why you need a public IP address on control planes. So you lose stuff like that. You also, for example, and again, I'm picking on AKS because I just wrote a report about this today, actually, so I'm happy we're talking about it. You have, for example, in AKS, you have configuration profiles for your clusters from standard to dev to the hardened mode. But if you want the hardened mode, and if you want to use things like the secret store CSI provider, and if you want to use things like Azure Policy, you have to pay more. So now you're not only paying extra, you're not only paying for the cloud provider, which is obviously a huge expense. That's why you're seeing a lot of talk nowadays where like the past maybe a month or so, people are like, we're thinking about moving back on-prem. So you have that, but now you have to pay extra for security. Now, in my opinion, I think security should be accessible without a huge price tag on it. So if you want to go that route, you should just spin up the standard clusters in AKS and EKS and GKE and just implement the security practices yourself. Another big gripe that I have is with some of the cloud providers that have managed Kubernetes services, you have to pay extra if you want a private cluster. You have to pay extra if you don't want a public IP address on your cluster. To me, that's I'll call it insane for the purposes of staying G-rated on the podcast. That's just kind of not fair, you know. So yeah, I have a gripe in the cloud with flexibility and feature sets with how you want to use it. And again, the stuff that I'm talking about right now, this may not be a big deal for many environments, but I'm talking about it because I've seen many environments not think it was a big deal until it was a big deal.
Yeah. So what's a person to do then? Like obviously it's almost like a metronome of going between sort of rolling your own versus cloud. What are you suggesting these days?
Yeah, so unfortunately, there's no right or wrong answer. Regardless of if you spin up the whole thing yourself on prem or if you spin it up in the cloud, you're going to face issues. The one issue in the cloud being the stuff that we just spoke about. Now, going on to the on prem side of spinning up Kubernetes yourself, it's a big lift. You need a lot of engineers. You need a lot of senior level engineers with specific level of advanced knowledge when it comes to spinning up a platform service at that level. So in the cloud, you give up certain control so you don't have to go through all of that. But you have to ask yourself, do you want to give up that level of control, or do you just want to kind of deal with it so you can get Kubernetes up and running? Because maybe you don't have the specific expertise in house. Maybe you don't have the consultants on hand that can do it for you. Maybe you don't want to go the consultant route. Whatever the case may be, there may be a reason that you want to use a managed Kubernetes service. And the primary reason that I hear is it's easier. True. But you got to peel back the onion a little bit and kind of look what's going on underneath the hood to confirm, yeah, it's easier, but as we all know in life, sometimes the easy road is not the best road. So, you kind of got to pick and choose what battle you want to go with. And that battle is going to be hit head on very differently depending on the organization that you're in. So Mercedes, again, saw this opportunity to do it themselves, and because they needed to do it in a particular way, and it worked out great for them. But let's say you have a startup with 6 engineers. They don't have the time to spin that thing up on prem. They don't have the time to monitor it. They don't have the time to observe it and to maintain it. They may not even have the expertise in house to get this thing deployed. So it's going to be one of those things where, unfortunately, there's not a right or wrong answer or a yes or no answer. It really comes down to which option's going to work best for your environment.
In another recent report, Dynatrace talked about various aspects of Kubernetes that folks see in the wild. And when talking about workloads, so let's switch gears talking about that. This is what was reported as the top workload categories and the change over time from 2021 to 2022. As you can see, obviously, observability is obviously a key aspect of this. But database, 48%. For a long time, people would say, nah, database is not, Kubernetes and databases doesn't make a lot of sense. But that's rapidly changed over the recent months and I guess years, plural. What's been your observation there relative to databases?
Yeah, so I think it comes down to what Kubernetes was created for versus what Kubernetes is being utilized for now. Kubernetes was created for stateless workloads. It was not created for databases. That wasn't the intent. However, with stateful sets, with the ability to have volumes, even with the ability to have containers point to a database, say in RDS, in AWS using RDS or something like that, because of the rapid growth just in stateful style applications and the ability to save your data, I think running Kubernetes in a pod is a perfectly fine way to do things in today's world. Databases, really what it comes down to is, can you have a stateful workload? Can you save that data somewhere? And the answer to both of those are yes, for inside of Kubernetes. So
Security is also listed plus 55% as a workload. And I want to kind of bring this back to the book. Obviously, one of the things that you talk a lot about in the book is the fact that there's some aspects to managing Kubernetes and deployments, which obviously speak to RBAC and scanning. Can you talk a little bit about the challenges there?
yeah, so I'm happy to see this 55% number here, because I feel like security is always on the back burner for everybody. So I think it was last year's report, Red Hat's State of Kubernetes report, and I forget the numbers. I've read these numbers a million times and I still don't remember them. I think it was like 70 or 80% of security issues right now are due to misconfigurations. And I talk about that a lot in the book, where I talk about here's the reality that we live in. People need to learn Kubernetes and people need to deploy it, but they don't have the time because they're doing a million other things in their job. With that being said, how do you become an expert or an advanced engineer or advanced user for something that you don't have time to do? Now, this goes back to misconfigurations. If nobody has the time to do it, if nobody's getting the proper training, if organizations aren't giving engineers the proper time to learn and get adapted to Kubernetes, of course there's going to be misconfigurations. It's how it is with anything that we do in life. If we don't have the time to do it, we're not going to do it the right way. So when I read that report, I was like, yeah, this makes sense that, nobody knows how to configure this thing properly. And because of that, of course, there are going to be a ton of security issues. So that's really where tools like, cluster scanners, container image scanners, pod scanners, even there's code scanners. So you can scan your Kubernetes manifest, and as you should. I remember John, a couple of years ago, we had a big conversation which always stuck with me, defense in depth, right? Talking about what you should be doing, how you should be thinking about things before they occur, just not trusting anybody. And I think about that a lot with Kubernetes manifests. Like, yeah, it's YAML or JSON, but you should still be scanning it for best practices. You should be scanning it still for security protocols, because you don't know what's going to happen. You don't know who's writing what misconfiguration may lead to a security issue down the road. And there are a lot of different tools that help you with this. There's Kubebench, there's Kubescape. There are, a bunch of different ways. There you can do container image scanning in a lot of these different tools as well. You can use JFrog's Artifactory scanner, or X-Ray. I think it's called X-Ray, yeah, to do these scans. So there are so many different ways that you can do this, and a lot of them are free. A lot of them are open source. So if you look at Kubescape, for example, you can do all of the scanning from a cluster perspective to the code in your Git repo for where your Kubernetes manifest exists. And this is all open source, by the way. So there's really nothing that should be stopping you from doing this at this point. Scan all your stuff, make sure everything's secure. Gloss over the CIS benchmarks for Kubernetes, because it's like 300 pages long. So I'm not asking you to read the whole thing, but gloss over it and understand what's happening.
In terms of configuration, what would you recommend there? Now, obviously, I would gravitate towards something like Terraform, and I look at something like, I look at the State of Octaverse report from GitHub, and they say that HCL is the fastest growing language at GitHub. Obviously, that speaks to the fact that a lot of people are doing infrastructure as code. Are you a fan of Terraform? Is that what you would recommend for folks who are not enforcing, but rather configuring? Let's get our words right, John. For those folks who are configuring their Kubernetes deployments, and do you see it as a way of that sort of enforcement that we just talked about relative to RBAC?
Absolutely. So I see this on two sides of the spectrum here. Is Terraform the only tool that you can use? No. I actually have a client right now that I'm working with them for their Kubernetes environment, and they've decided to use Pulumi and TypeScript because the developers that are deploying their infrastructure as code are all familiar with TypeScript. So in that particular environment, TypeScript and Pulumi makes more sense. However, does Terraform make more sense overall? Yes, and I'll tell you why. Not because it is, well, maybe it's the best. I don't know. I don't pick sides. Whether it's the best, whether it's the fastest, whatever, that's not even the point. The point is that there's so much documentation and so much support around the two topics, Terraform and infrastructure as code. There's so much documentation out there, so many videos, so many live trainings, so many blog posts. Because of the sheer amount of support out there around Terraform, that's always why I recommend it. And I say this in every production environment that I'm in. Don't pick a tool because it's the hot new sexy thing. Pick a tool because it's really well supported. Because if it's really well supported, it may not be the hottest thing right now, but you're never going to have a time where you can't figure out an issue.
Yeah, I realize we're covering a huge swath of concepts here, but that's Kubernetes. Kubernetes is massive, so there's a lot of stuff to talk about. I also wanted to touch a little bit about what you covered in your book, which is deployment. This is part 3 of your book, when you talk about actually getting this stuff into production and around what you have available around CI/CD. Obviously, the fact that Octopus Deploy is a deployment solution, I won't mention that too much, but if you're looking at deploying solutions there, we have a solution for that. But tell me a little bit about some of the things that you're thinking about relative to that space. Like, what are engineers, what are platform engineers thinking about? What is DevOps thinking about relative to this space around CI/CD and Kubernetes?
Yeah. So originally, I would say CI/CD was the thing for not only deploying your cluster code, but deploying your Kubernetes manifests and your Helm charts and your customized configurations and all of that, because you needed an automated way to get all this stuff deployed in your cluster. Now things are changing a little bit. You have GitOps. So you have Argo CD and you have Flux and you have a ton of other solutions. And These solutions, in my opinion, are the de facto standard right now for application deployment. Cluster deployment stuff and Terraform code and all that should still always, of course, be done via CI/CD. Application workloads, I believe, should be moving more towards GitOps now. And the reason why is because GitOps is like configuration management for your Kubernetes environment. It the controller, the GitOps controller, again, whether it's the Argo CD controller, the Flux controller, whatever, it looks at your source control repo, looks at your Kubernetes manifest, your Helm charts, your customized configurations, and it automatically deploys them for you. If something changes in your repo, if you change your replica count from 2 to 3, the GitOps controller will see that based on the interval that you set up, 30 seconds, 5 minutes a day, etc., and it'll automatically deploy it for you. That makes more sense from an application perspective versus having it in a CI/CD pipeline and clicking deploy, 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 or regardless of, well, I guess it would depend, right? If you're using continuous delivery versus if you're using continuous deployment. But that's, again, the de facto standard that a lot of people are moving towards now. Then there is the other side of the token. And I feel like a lot of people aren't talking about this for whatever reason, and it bugs me. GitOps is great. You got your Argo running, you got your Flux running, everything's groovy and great. But how do you get the Argo CD controller on your cluster? You got to deploy it somehow. You got to run those commands to get Argo deployed so you can manage your application stacks with it. And again, I think that's where you kind of go back to the CI/CD piece. The CI/CD piece still needs to deploy certain higher level services and controllers. Now, let's say you take a CI/CD pipeline and you deploy your Argo controller to your Kubernetes cluster. At that point, Argo can manage everything for you from an application stack perspective, but you still need to take a step back and say, okay, cool, but how do I get Argo deployed? And that's, again, where, I think CI/CD comes into play, or CD rather, not the CI piece.
And so what would you recommend for bootstrapping all of that?
Well, of course, Octopus Deploy. We'll talk about that. But so I see a lot of GitLab, to be honest, in most enterprise environments that I work with. And these are 10-person startups to 2,000-person companies, not just in the US, all around the world. I see a lot of GitLab. Now, I don't know if it's because of the feature set or because the licensing model or because, GitLab support team, or, I know a lot of like consulting companies will partner with them so they get, better prices for their clients and stuff like that. I don't know what the reasoning is, but that's what I see a lot of. The other one that I see a lot of as well is GitHub Actions, simply because code is sitting in GitHub. People see workflows. It's all kind of there for them, and they can deploy it easily. So I would say those are the two biggest ones that I see.
Now, you mentioned earlier that you would espouse the fact that a lot of this wants to be based around GitOps, which is, I think, for a lot of folks, it can be a hard sell because they're like, this is not the way I normally am used to working, right? Like, is GitOps is the body going to reject the organ when talking to folks around GitHub?
Yeah, so it's a good question. It's definite. Well, so it's funny. I get the question a lot, and the way that I essentially explain it at a high level is it's different, but it's not. What we're doing is, number one, we're taking a controller, which if you're working in Kubernetes, you know what a controller is. You have your deployment controller and your ingress controller, and every resource that's deployed in Kubernetes that has an operator, you have your controller. So that concept is the same. And then you have the other piece of it, which is essentially, like I said earlier, configuration management. So if you peel back the onion and you see, oh, GitOps is just a controller that's sitting in Kubernetes that's doing my configuration management for me. If you think about it like that, it's way less scary, because the interesting yet funny yet ironic yet I don't know what else thing about Kubernetes and the different third-party tools and services like Service Mesh and GitOps, etc. This isn't revolutionary stuff. This is stuff that we've been doing for the past 10 years. It's just wrapped up in a bow and called something else and packaged up a little bit differently. Like you think about Service Mesh and you think about what it's doing for helping us with latency, helping us with, east-west traffic encryption, helping us with overall network encryption. Like these aren't new things here. These are things that we've been doing. It's just packaged up and sent and deployed and managed differently. That's all.
Let's round things off by talking a little bit more of the practical side of quote unquote managing Kubernetes. And managing is a very nebulous term to include observability and cost analysis, etc. We talked a lot about these things already. There's obviously a bunch of very popular solutions in market today. I'm thinking of your Prometheuses, your Grafanas, your Datadogs, etc. What are you recommending to clients these days in terms of that management side, the observability side, telemetry, etc.?
Yep. So I think you have two sides of the coin. You have your, I'll call it the enterprise route, and then you have your homegrown route. So if you're trying to save costs, but if you know you need observability and you need monitoring, et cetera, Prometheus and Grafana are a great stack. Do keep in mind, a lot of people call Prometheus an observability tool, but really it's a metrics tool because it's not doing tracing for you and it's not doing logging for you. So if you need tracing, if you need logging, you probably definitely need logging. Maybe you need tracing. You're going to have to look at another tool for that, like logs.io or something like that. Now, with that being said, you're piecing these tools together, you're managing them. Again, is it possible? Absolutely. But you need more engineers to do it because you have to piecemeal all the stuff together. You have to manage it all, etc. Now there's the enterprise route, which, I see a lot of Datadog, I see a lot of New Relic, I see a lot of container insights in AWS for CloudWatch. I see a lot of app insights if you're in the Azure space. So really what it ultimately comes down to is number one, do you want to spend money on tools? Or number two, do you want to spend money on people? Either way, you're spending money. You just got to pick. Are both options very usable in production? Absolutely. Do both options work? 100%. Very well. Both of them work. It just really all depends on what you want to spend money on, really.
So the book is 50 Kubernetes Concepts Every DevOps Engineer Should Know. It's available from Pact Publishing. Uh, Michael Levan, thank you very much for joining me on the show. I really appreciate it.
Absolutely, John. Thank you so much for having me.